All right, join me on page 298 of your science textbook. Can earthquakes happen anywhere? An earthquake is a trembling or shaking of the ground caused by the release of energy following movement along a fault. Some of the most damaging earthquakes in U.S. history have happened in the state of California. In fact, in the last 300 years, California has been shaken by 76 strong earthquakes that have caused loss of life and extensive property damage. Continuing on page 299, fault zones. Faults are breaks or cracks in the rocks of the lithosphere, along which movements take place. Fault zones are areas where there are many interconnected faults. Most faults and fault zones are located along the boundaries between tectonic plates. When stresses within Earth become great enough to overcome the strength of the rocks along the faults, the rocks move and energy is released, producing seismic waves, also called earthquake waves. These vibrations radiate away from the earthquake. An earthquake can be one of the most destructive of Earth's natural forces. Only a few earthquakes cause serious damage. In California, earthquakes are common in the fault zone that includes the San Andreas Fault. Okay, turning the page to page 300. How do scientists learn about earthquakes? Scientists study seismic waves to find out where earthquakes begin and how strong they are. They use a special tool called a seismograph. A seismograph is an instrument that detects, measures, and records the energy of earthquake vibrations at a given location. Seismograph stations are set up all over the world. Many of them are near one another. As the ground vibrates, a roll of paper in the seismograph vibrates with it. A pin is suspended above the roll of paper with a heavy weight attached to it to keep it steady. The pin held above the roll of paper does not vibrate with the ground. As the roll of paper turns, the pin traces a record of vibrations that appear as wavy lines on the paper. These wavy lines represent P waves and S waves. These waves start at the same time and place, but P waves travel faster than S waves. The difference between their arrival times at the seismograph enables scientists to calculate the distance the waves traveled to reach the stations. To understand this, think about a thunderstorm. People see the flash of lightning before they hear the clap of thunder. This is because the light waves travel faster than sound waves. When there is a little time between the lightning and the thunder, people know that the storm is some distance away. When the lightning and the thunder happen at almost the same time, people know the storm is nearby. This concept applies to earthquake waves. Okay, continuing on page 301, using a seismograph. Seismographs can also help scientists find an earthquake's focus and epicenter. The focus is the point below the surface of Earth where an earthquake begins. The epicenter is the point on the surface of Earth directly above the focus. It is the place where the strongest shocks are felt and where the greatest damage usually occurs. To locate the epicenter, scientists use triangulation. Triangulation is a way of using information from at least 3 seismograph stations to find the location of the epicenter. To pinpoint the epicenter, a circle is drawn around each seismograph station on a map. The sizes of these circles show how far away the earthquake was in all directions from the station. The place where all 3 circles intersect is the approximate location of the epicenter of the earthquake. So you can see here, if you look on your screen, the epicenter for this earthquake would have been right about here. Okay, where all 3 of those circles intersect. And then you can see there's another example of it on page 301 in your science textbook. All right, thanks again for watching, and I will see you on the next one.